I'm going to do question 2 now from the Gauteng Education Department's Prelim Paper, Paper 1, which is the physics paper from 2020. This is a Newton's Laws question. Most of this question is applicable to grade 11, and all of it obviously is applicable to grade 12. So when we get to the part that's not applicable to grade 11, I will let you know, but hopefully you'll still learn from it, alright? So, and as a proviso, this is my memo. It's not taken from the official memo in any way. In the diagram below, a drone with a mass of 5.8 kilograms is used to lift a mass, which is 33.2 kilograms. So we've got a drone, there's its mass, there's the mass of the object, by an inextensible cable of negligible mass. We're just trying to reduce the variables, okay? So the cable really is irrelevant. The tension in the cable is T, and the drone accelerates vertically upwards at 0.9 meters per second squared. The lifting force of the drone is 180 newtons, not on the drone, of the drone, okay? The lifting force of the drone is 180 newtons. So the drone's pulling up with 180. The frictional force F experienced by the drone and the mass M as they move upwards is the same. So we're quite happy with that, but what we need to recognize here is that friction will act down. They're moving up. Friction opposes the motion, so friction's going to act down. First question is to state Newton's second law in words. Okay, I just want to give myself some lines here so that I can actually write in a straight line for you. Now, state Newton's second law in words of motion in words. These are non-negotiable in our exams, okay? So this really is something that should become second nature to you. And remember, so for 2.1, when a resultant, please, you need to have this word or you get naught. When a resultant force acts on a body or an object, probably should say on an object, the object accelerates in the direction of the force. Now be careful. With an acceleration. Please don't leave out this part, with an acceleration, because I see it quite often where you go accelerates in the direction of the force and it's directly proportional to, and that doesn't, you're telling me the force is directly proportional to things, so that doesn't make sense. So you're going to tell me with an acceleration that is directly proportional to the force and inversely, not indirectly, but inversely proportional to its mass. Okay? Definitions and laws not optional to learn. Now they say, draw a fully labeled free body diagram for the mass M. It's only worth 3 marks. That means there's only 3 forces acting on it. Here we need to just think through this carefully because the force of the drone becomes an issue. The force of the drone is only acting on the drone. It's the engine of the drone, essentially, and it's the blades and all the rest of it. The forces that are acting on the mass are tension, friction, and gravity. Those are the three. Alright? So, free body diagram. We have a dot. We have tension. Now you may write that as FT. I'm keeping it as T because they labeled it as T. So T, which is tension. We have FG. You may see this labeled as W, which is gravity or weight, the force of gravity. And then the big one, which you need to be careful with, friction. Please remember, it said draw a label diagram, which is pretty much what you're always going to be asked to do. You need to give a key. You need to tell me what each of these are for. We're good. Now we get to the fun question. Why do I say it's a fun question? Because it's worth 7 marks, which means there's lots to do with it, okay? So you look at it and you go calculate the magnitude, size, of, let me see if I can get something that'll show up on here. The magnitude of the frictional force, okay, they don't want to show up on here. Magnitude of the frictional force experienced by the drone and M. The nice thing is both of them have the same friction. I have two objects that are moving. That means I need to look at them separately. And this sounds a lot more difficult than it actually is. So a lot of you look at this and go, oh, I've got so many unknowns. No, we don't. Okay, remember, you separate this out into two systems. So 2.3. If I look at the drone, at mass M, mass M, we already know what the free body diagram looks like, right? So F net equals MA. So for the mass, we're going to have tension, because that's the first one, minus friction, because it's acting in the opposite direction, minus Fg equal to MA. I don't know T. I don't know friction. Fg is 3,2 times 9,8. Mass is 3,2, and they told me it was accelerating at 0,9. So T minus F, and I've taken the 3,2 times 10 to the 9,8 over to the other side, added it, and we get 34,24 newtons. That's my first equation. Now if I consider the drone has the 180 newtons acting up. It has its Fg acting down. It has tension acting down. And it has friction acting down. And right about now you're going, oh, there's too many. No, there aren't. Watch. F net equals MA. Okay, I'm going to make this a bit bigger and we'll reduce it in a second. Which means we're going to have 180 minus tension minus friction minus Fg equal to MA. So 180 minus tension minus friction minus 5,8 times 9,8 equal to 5,8 times 0,9. Okay, I'm taking all the constants to one side, keeping all the unknowns on the other. So minus T minus F minus 117,94 meters. Okay, now we have two equations. So that's my second equation. How you solve for F from here is up to you. It doesn't matter. I like to add my two equations together because if I've set them up correctly, then the tensions cancel out. So if I now add my two equations, so I had T minus F equal to 34,24 newtons, and I've got minus T minus F equal to minus 117,94. Okay, I've got a positive T minus T, brilliant. So I end up with 2F, and I end up with minus 83,7. I'm not too fussed about the minus, because it's now going to be divided by minus 2 on both sides. Friction is 41,85 newtons. Nice and straightforward. Okay? So don't have a moment over something before you really need to, because that's what we do sometimes. Sometimes we get all like bent out of shape and we get all anxious over something that we don't need to. Even though it looked worse than it was, it's really not that bad. Okay? Then they said to us, let's go back to the question. So now I know that the frictional force was, what did we say? 41,85 newtons. Now they say calculate the tension in the cable. This is a carry down question. If you got 2.3 wrong, we'll carry down whatever answer you get to 2.4. 2.4, you need to use one of the equations you had set up. I'm going to use the first one I set up because my tension's already positive. So I'm going to have tension minus 41,85 equal to 34,24. So tension is now 34.24 plus 41.85, 76,1 newtons. Tension you cannot give me a direction for, because tension is acting down on the drone and up on the mass. This last question now is grade 12 only. Here we now adding a little bit of what you learned from work, energy and power. So grade 11s, if you're watching this, you won't know how to do this question yet. You will when you get to grade 12. They tell you the drone reaches its maximum constant speed of 19,7 meters per second after reaching a point X. The lifting force doesn't change. So in other words, it still has a force of 180 newtons. They want the power of the motor. You have a force, you have a constant velocity, and you want power. They want you to use, so this is 2.5. Average power is force times your average velocity. It's 180 times 19,7, 3,546 watts. It's as simple as that. Don't make it more complicated than it is. Hope that helps, and subscribe to get more videos.